A stationary tuning fork is in resonance with an air column in a pipe. If the tuning fork is moved with a speed of 2 meters per second in front of the open end of the pipe and parallel to it, the length of the pipe could be changed for resonance to occur with the moving tuning fork. If the speed of sound in air is 320 meters per second, the acknowledged value of the percentage change required in the length of the pipe is. Okay, so IIT Advanced 2020 paper 1 question number 17. Now we have a pipe, so it is an open pipe, and we will have two cases. Now initially this is the tuning fork having a frequency f0 in resonance with one of the modes of vibrations of the pipe. Now we know that for an open pipe, now they are talking about open end, so we can assume that one end is closed and one end is open. So the frequency of oscillations in the pipe will be given by odd multiple of V by 4L, where L is the length of the pipe. Now, for resonance, 2L minus 1 V by 4L is equal to F0. Now the tuning fork is moved away with a speed V equal to meters per second. So the apparent frequency for the pipe will now be C plus 0 upon C plus V into F0, or F will be equal to F0 into 1 plus V by C raised to minus 1, and that can be approximated to F0 1 minus V by C. Now the frequency of the sound coming from the tuning fork has apparently decreased. The length of the pipe will also decrease by some amount, and let the new length be L minus delta L. So the new frequency of oscillations in the pipe will be 2n minus 1 V upon 4 L minus delta L. Now, for resonance, f naught 1 minus v by t could be equal to 2n minus 1 v by 4l 1 minus delta l by l. Also, please note that the frequency of the tuning fork has decreased, so the frequency of oscillations in the pipe should also decrease, and therefore I will take it as L plus delta L. Let me make it more clear. ट्यूनिंग फॉर्क से जो साउंड आ रही है, ट्यूनिंग फॉर्क के मोशन की वजह से उसका अपैरेंट फ्रीक्वेंसी कम हो गया है। तो अगर हमें रेजोनेंस कंडीशन लानी है तो पाइप के अंदर जो वाइब्रेशन हो रहे हैं उनका फ्रीक्वेंसी भी हमें थोड़ा कम करना होगा ताकि वो ट्यूनिंग फॉर्क का फ्रीक्वेंसी से मैच कर जाए। अब ट्यूनिंग फॉर्क की फ्रीक्वेंसी से मैच कराने के लिए हम ये मान के चलेंगे कि पाइप का लेंथ थोड़ा डेल्टा एल अमाउंट से बढ़ा दिया गया, and therefore new frequency in the pipe will be 2n minus 1 v upon 4, लेंथ हो जाएगी l की जगह l plus delta l, so this will be equal to 2n minus 1 v by 4l into 1 plus delta l by l raised to minus 1. Now f naught और 2n minus 1 v by 4l बराबर हैं, तो you get 1 minus v by c is equal to 1 plus delta l by l raised to minus 1. This is approximated to 1 minus delta L by L. Therefore delta L by L जो आया वो V by C आ गया, और percentage change in length 100 into delta L by L, so it is 100 into V by C, 100 into 2 by 320, so it is 5 by 8, 5 by 8 हो जाएगा 0.625%, and therefore allowed answer will be 0.62 to 0.63 as per the official answer key. Now IIT lecture 18 paper 1 physics. Now, a circular disk of radius r carries a surface charge density sigma r equal to sigma naught 1 minus small r by capital R, where sigma naught is a constant and r is the distance from the center of the disk. Electric flux through a large spherical surface that encloses the charged disk completely is phi naught. Electric flux through another spherical surface of radius r by 4 and concentric with the disk is phi. Then the ratio phi naught upon phi is. Alright, this problem is based upon the application of Gauss law. First, let us find the charge q on a disk of radius r. So this is the bigger disk of radius capital R, and this is the smaller disk of radius small r. Now let us consider a disk inside whose radius is x, and let the thickness of the disk be equal to dx. So the area of this strip is 2 pi x dx, and let the charge on this strip be dq. So dq by dA, that is dq upon 2 pi x dx is equal to sigma, and this will give you dq is equal to 2 pi sigma x dx. Now as per the question, sigma is equal to sigma naught 1 minus x by capital R. Therefore, dq will be 2 pi sigma naught x minus x square by r. So charge a small q on disk of radius small r h 2 pi sigma naught integration of x dx from 0 to small r minus integration of x square by r dx from 0 to small r, and q will be equal to 2 pi sigma naught x square by 2, it will be r square by 2 minus x cube by 3r, so it will be r cube by 3r. Now suppose this is the bigger disk of radius r having a charge q, and this is the smaller disk of radius r by 4 and having a charge q dash. So q will be equal to, by this formula, 2 pi sigma naught r square by 2 minus r square by 3. So Q will be equal to pi sigma naught r square by 3, whereas Q dash will be 2 pi sigma naught r by 4 square by 2 minus r by 4 cube upon 3r. So this will be equal to 2 pi sigma naught r square by 32 minus r square by 192. So Q dash is equal to pi sigma naught r square into 5 by 96. Now Q by Q dash is equal to 1 by 3 into 5 multiplied by 96. So that will be 32 by 5, and this will be equal to 6.4. So now we know that the disk of radius r by 4 has a charge q dash, whereas the disk of radius r has a charge q, where q upon q dash is 6.4. Now the bigger sphere is enclosing the disk of radius r, so the electric flux through this will be phi naught equal to q by epsilon naught, whereas the smaller sphere whose radius is r by 4 will only enclose a disk of radius r by 4, or it will enclose a charge q dash. So the electric flux through this will be phi equal to q dash by epsilon naught. Therefore, phi naught upon phi is equal to q by q dash, and the correct answer is 6.4. So the ratio of the two electric flux will be 6.4. Hope this is clear. Thank you. As per answer key and as per the instructions given in the paper, the answer will be taken as 6.40.